Hello students, today we are going to discuss the valence shell electron pair repulsion theory. So valence shell electron pair repulsion theory. In this theory we will discuss about the geometry and the shape of molecule. Now the statement of VSEPR theory is the geometry and the shape of molecule, the geometry and the shape of molecule depends upon the bonding electron pairs, depends upon the bonding and also on non-bonding electron pairs, So what are bonding electron pairs and non-bonding electron pairs? Let's see. Suppose we have a molecule AB2. So we will draw its geometry and it has two lone pairs like this. So draw its geometry. We know that it has bend shape, and here this is the molecule. So the electrons that are take part in bonding, two electrons that are take part in bonding are called bonding electron pair, and the lone pairs are called non-bonding electron pairs. Non-bonding electron pairs. So this is bonding electron pairs, this is bonding electron pairs, and the lone pairs are called non-bonding electron pairs. Now the VSEPR theory tells that the geometry of the molecule depends upon the bonding pairs and non-bonding electron pairs, that is lone pairs. Now we will discuss the VSEPR theory in 4 points. So first point we have, if the central atom, suppose we have a molecule ABN, here central atom A have only bonding electron pairs, Central atom have only bonding electron pairs and it have not non-bonding electron pair, that is A does not have lone pair, it have only bond pairs. So the geometry of the molecule is regular, that is linear, trigonal, planar, tetrahedral, trigonal, bipyramidal, octahedral, pentagonal, bipyramidal. So let's discuss what are regular geometries of the molecule if the molecule only have the bond pair and no lone pair is present. So I will make a chart. So bond pairs here, hybridization here, and here we have the geometry of the molecule. So if a molecule have two bond pairs, only two bond pair, then hybridization as we know is sp, and the geometry of the molecule is linear. Now if the molecule have three bond pairs, then the hybridization of molecule is sp2 and the geometry is trigonal planar, that is like this. It is trigonal planar. Molecule has geometry trigonal planar. Now if the molecule have four bond pairs, then the geometry is sp3. Don't be panic, I will explain what is bond pairs again by taking example. So if the geometry of the molecule have four bond pair, so hybridization is sp3 and the shape is tetrahedral. Shape. So what is tetrahedral shape? We know that methane have tetrahedral shape. So this is the tetrahedral shape. Now if the molecule have five if the molecule have 5 bond pairs, then the hybridization is sp3d. sp3d, and the shape is trigonal bipyramidal. So let's taking example A, B, 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 and B. So this is trigonal and this is bipyramidal shape. One pyramid above and one pyramid below. Make it clear. I will make it clear. So this is the trigonal bipyramidal shape. We have A, this is the trigonal bipyramidal shape. In this way, trigonal bipyramidal shape is drawn. Now, if the molecule has 6 bond pairs, then the hybridization, as we know, is sp3d2, and the shape is octahedral. So, octahedral shape, as we know, 4 atoms are in plane and 2 atoms are above and below the plane. So this is octahedral symmetry. This is octahedral, OCTAHEDRAL, octahedral symmetry. Now, if the molecule has 7 bond pairs, then the hybridization is sp3d3, and the shape of the molecule is pentagonal bipyramidal. So, pentagonal bipyramidal, we have, if A is the central atom, then the pentagonal bipyramidal shape is drawn as here B atoms are present and 2 atoms are present above and below the plane. These 5 atoms, 1, 2, 3, 4 and 5 atoms are in plane, and these atoms are above and below the plane. So now let's take the example of all these structures. So here, if the molecule have 2 bond pair, so hybridization is sp and the shape or geometry of the molecule is linear. Then we will discuss the examples. So we have example of this shape is BeCl2. Now if the bond pairs are 3, hybridization is sp2, then the molecule is trigonal planar and its example is BF3. BF3 have trigonal planar shape. Now again we will, if the molecule have 4 bond pairs, then hybridization is sp3 and the shape is tetrahedral, and we have taken example of methane, that is CH4. Now again, if we have 5 bond pairs, then the hybridization is sp3d and the shape is trigonal bipyramidal. So we have the example PCl5. So PCl5 have trigonal bipyramidal shape. Now again we have, if the bond pairs is 6, and so hybridization is sp3d2, and we have the shape of the molecule is octahedral, we have example SF6. Again, for 7 bond pairs, we have the hybridization is sp3d3 and we have the shape of pentagonal bipyramidal, and example of this shape is IF7. So in this way we have discussed the first rule for the hybridization, for the VSEPR theory. Now the second rule we will discuss in the next video. So please join us for and subscribe my channel for getting the latest updates. Thank you very much.